In this video, I will be explaining linear project number 2, and for this project, you will be creating a line drawing on graph paper, and then you will write the equations and constraints for those lines using the recording sheet provided. And here's a little checklist to make sure that you have everything done correctly. You're going to receive 5 points for having a drawing on graph paper and making sure those lines are connected using a ruler and that you have numbers on your lines. Just a note, you do not need to number every single line in the picture, but the next item here will tell you how many lines you should want to number. You'll receive 20 points for a picture that contains at least 20 lines, and they should be a nice combination of sloped, vertical, and horizontal lines. So if you have a drawing that's made up solely of vertical and horizontal lines, you won't get the full 20 points. So make sure some of the lines are sloped. The next 20 points will be given for the equations and constraints that you write for the lines on your drawing. An A+ project will have a variety of formats, and I'm going to show an example of each of those in just a bit. Ways you can write your equations are in slope-intercept form, point-slope form, and standard form. Finally, you can put your project together in a professional manner by making a cover page and then making sure everything is stapled in order. For a bonus, you can type your equations and constraints in Desmos to recreate your drawing digitally. This is worth 50 points. It is a summative grade, so it will count for 80% of your quarter 4 grade. Notice on my sample drawing that not all of my lines are labeled. I have a total of 24 lines labeled, which puts me in the A+ range. I also have a variety of vertical, horizontal, and sloped lines, which puts me in the A+ range. I will now walk through how to write equations in different forms, starting with line number 9. So I went ahead and filled in line number 9 right here, and then I put the two ordered pairs, 11, 13, and 10, 14, that make up that line. Then I'm going to do this one in point slope, and when you're finding the slope, we can count up and count over to find out that the slope is -1, and we can also verify that by taking 14 minus 13, which is 1, and then 10 minus 11, which is a -1. So 1 over -1 is a -1 slope. You do not need to show this part, but you are welcome to. For the point slope format, it's y minus y sub 1 equals m times the quantity x minus x sub 1. So what I'm going to do is I'm just going to copy and paste this, and I'm going to type this in for you. Y minus y sub 1 means that I use one of my y values from one of my ordered pairs, so I'm going to use the 13. And then m, the slope, is -1. I've already found that. And then x minus x sub 1, the x coordinate for the one I chose is 11. So there I have my equation in point slope form. The last thing I need to do is write my constraints. And so if I look back up here at the top at line 9, if I draw a line straight down to the x-axis and straight down to the x-axis, notice that that line starts and stops at 10 and 11. So one of the ways I can write my constraints is by typing 10 less than x less than 11. That tells my line to start and stop at 10 and 11 on the x-axis. I could also go across to the y-axis and see that my line starts and stops at 13 and 14. So I could either use this as my constraint, or I could type in 13 is less than y is less than 14. Either one of those would be acceptable. For my next example, I'm going to be writing an equation in slope-intercept form. So you can see that I have written down line number 20 and circled slope-intercept, and I've listed the two ordered pairs that make up line 20. And to find the slope, I can count up and over right on my document. So that's up 3 and then over 2. Or I can do the math and say 7 minus 4 is 3, and then 15 minus 13 is 2. So in slope-intercept form, we have y equals mx plus b. Notice that I have substituted in the y of 7, so I used this ordered pair right here and substituted in 7 for y. The m I have substituted in 3/2, and then the x value that I am going to substitute in is 15, and then I'm going to solve for b. So 3/2 times 15 is 22.5, and so to isolate the b, I need to subtract 22.5 from the right side of the equation, and I also need to subtract that from the left side. So what I have is 7 minus 22.5, which is negative 15.5, and that's my b value. That is not my final equation. What I want to do is I want to substitute the 3/2 in for m and the negative 15.5 for b to write my final equation for this one, which will be y equals 3/2 x plus a negative 15.5, or just minus 15.5. Okay, and then the constraints, of course, for line 20, I can either use the 13 and the 15 for my x's, or I can go across to the y-axis and use my 4 and my 7. Either one of those will work for the constraints. For my last example, I'm going to write an equation in standard form, and my suggestion to you when you're writing in standard form on this assignment is to pick a line that has a slope of 1. And so I'm actually going to choose line number 1 right here that has a slope of 1, up 1 and over 1. So coming down here, line number 1, and we are going to write this in standard form. And the ordered pairs we have are 2, 5 and 3, 6. We've already said that the slope is 1, but we can verify that by taking 6 minus 5, which is 1, and 3 minus 2, which is 1. 1 divided by 1 is 1. The standard form equation is ax plus by equals c. But in order to do that, we're going to first start out by writing our equation in point slope form. So I'm going to take y minus one of my y values, which is 5, equals m, my slope, 1, times x minus the x value for that ordered pair, which is 2. And then I'm going to distribute the 1 right here to the x and to the 2. And that's pretty easy because we're just going to be left with y minus 5 equals x plus 2. Now, standard form has x and y on the same side. So the next step that we're going to do is we're going to subtract x from the right side, and then we're going to subtract x from the left side. So what we have now is negative x plus y minus 5, and then this x is gone, and we have negative 2 on the right side. The next step will be to get rid of that negative 5 by adding 5. So plus 5 and plus 5 to this side. What we're left with is negative x plus y equals a positive 3. And that coefficient of the x should not be negative, so I'm going to multiply the whole thing by negative 1, making negative x a positive x, y a negative y, and 3 and -3. So that is your equation written in standard form. To get there, we first wrote the equation in point slope form, did some distributing and getting things on the right side, or in this case, the left side right here, to get the equation. You could also write it in slope-intercept and then again get the x and the y to the same side. Either way will work. But try to do a couple of your lines in standard form. I know it's not the easiest method, but an A+ project will have a couple of lines written in this format. So to start the project, you're going to draw an image on the graph paper provided. Make sure that you use a straight edge or a ruler to connect all of your points. Remember that an A+ project will have at least 20 lines. You can have more, but make sure that at least 20 are numbered on your drawing. The recording sheet is where you will write the equations and constraints for each of your lines. Make sure to label the lines and also circle the format that you're writing the equation in. An A+ project will have 20 lines written correctly along with their constraints and in a variety of formats, including slope-intercept, point slope, and standard form. For bonus points, you can type in your equations and constraints in Desmos to recreate your drawing digitally.